Video is for the Laws of Exponents foldable notes. So we're going to get started here. The first page is talking about the product of powers. So the product of powers says that x to the m times x to the n is the same as x to the m plus n. So if the leading values here, the base, are the same, you can add their exponents. So for a numerical expression, if I have 2 to the second times 2 to the third, I can change that to 2 to the 2 plus 3. I can add those. 2 plus 3 is 5. So 2 to the second times 2 to the third is the same thing as 2 to the fifth. If I break it down further, that's 32. So numerical are easy because we can check with our calculator. So algebraic. So here I have x to the third times x to the 4/3 times x to the 2/3. So what I can do here is I can add all the exponents. So x to the third plus 4/3 plus 2/3. And you can use your calculator just to add those up. That equals x to the, let's see, 3 plus 4 plus 2 is 6. 6 over 3. 6 over 3 is the same as 2. So this is the same as x to the 3 plus 2, which is the same as x to the fifth. So this expression is the same as this expression. And then if we have an algebraic, maybe we want to solve for one of these. So here, if I simplify this down, 2 to the negative nth times 2 to the third is the same as 2 to the negative n plus 3. And that is equal to 2 to the 14th. So when we have these set equal like this, that means this exponent equals this exponent because the bases are the same. Since both the bases are 2's, that means the exponents have to equal each other. So negative n plus 3 equals 14. And if I solve that equation, n is going to equal negative 11. All right, quotient of powers. So now, if we have it set up like this, like a fraction, or we're dividing, we're using division, say that's a division sign. It's the same as taking the base, as long as the bases are the same, and subtracting. Now, when you subtract, whichever exponent comes first or is on top of the fraction, it's first in the subtraction problem. So if I have 3 to the 10th over 3 to the 5th, this is the same as 3 to the 10th minus 5. Okay, so 10 minus 5 is 5. So 3 to the 5th is 243. All right, algebraically. So again, I know my bases are the same because they're both x. Okay, so x to the 33rd over x to the 53rd is the same as x to the 33rd minus 53. So 33 minus 53 is a negative 20. And anytime that we have a negative exponent, this is the same as putting x to the 20th, changing it to a positive exponent, and putting it under 1, or dividing 1 by this. Okay? All right, so now we've got an algebraic. X to the 75th equals x to the 8n over x to the 3n. So what we know here is x to the 75th is going to equal x to the 8n minus 3n. Okay? So bases are the same. That means 75 equals 8n minus 3n. And 8n minus 3n is 5n. And again, if we solve this, n is going to equal 15. Okay? All right, our next section is a power to a power. And so that means x to the m in parentheses, and then raising all of that to the nth is the same as multiplying those two exponents. Okay? So 2 squared to the 3 over 2 is the same thing as doing 2 and then multiplying 2 times 3 over 2. So if we multiply 2 times 3 over 2, we just get 2 to the third. That 2 will cancel out down there. And 2 to the third equals 8. Okay? X to the fourth and then to the fifth is the same as x to the fourth times the fifth power. 4 times 5 is 20. So a lot of this is just simplifying expressions, making them a little bit neater and easier to work with. Now we've got a good complex one here, because now we are using the quotient rule and the power to a power. Okay, and then we're using the product rule here. So let's simplify this first. X to the 4n over x to the 9n is the same as x to the 4n minus 9n, and then keep that exponent. And then here, x to the 72nd times x to the 8n is the same as x to the 72 plus 8n. Okay, now we need to simplify this piece. Okay, so 4n minus 9n is x to the negative 5n, and it's still squared, equals x to the 72 plus 8n. So we just take it a chunk, a piece at a time. All right, negative 5n, and then we're raising it to a 2, so we can multiply negative 5n times 2, which would give me x to the negative 10n, and that's going to equal x to the 72 plus 8n. Sorry if space is kind of limited there. Which means, since the bases are the same, I can set these equal to each other. Negative 10n equals 72 plus 8n, and now I have an equation I can solve. So if I combine like terms, I would have negative 18n equals 72. N is going to equal negative 4. All right, negative exponents. So we kind of talked about this in one of the previous examples. If we have x to the negative m, it's the same as 1 over x to the positive m. So I've got 9 to the negative 1 over 4, and then I'm raising it to the 1/2. What I want to do here is I want to break this down further into exponents, okay? So 9 is the same as 3 squared. 4 is the same as 2 squared. So you can do that too. You can unsimplify a problem as well. So what I'm going to have here is 3 squared to the negative 1 over 2 squared, and then raise it to a 1/2. So when we've got exponents stacked like this, we can just multiply all 3 numbers. So I've still got a fraction here, 2 times negative 1 times a 1/2. 2 times negative 1 times 1/2. And then this 2 would be 2 to the 2 times 1/2. All right, so now we can multiply out. So the reason I broke this down is because the 2 and the 1/2 are going to cancel each other out, and I'm going to be left with 3 to the negative 1 over, this is going to cancel, so I'm going to be left with 2 to the first. Okay, here's where things get kind of sketchy. 3 to the negative 1 is the same as 1 over 3 to the positive 1. But I still have this 2 to the 1 on the bottom. Okay, and we would just multiply those together. So 2 to the 1 is just 2. So really what I have down here is 2 times 3, and then I would have 1 to the 6th. Okay. All right. Now we got a big time one here. All right, we have got negative 5x squared times 3y to the third, 2z to the negative second, and then all of that times 3. I'm wondering if that should be, I think that should be to the third power. You know what, we're going to skip this example for now. remind me, let's look over this one together in class, okay? All right, rational exponents. So rational exponents, well, let me find it real quick. There it is. Okay. So we have this thing called an index. That's the n. If it's just a regular square root, that's just a 2. It's assumed to be a 2. But there's other numbers that we can put there. So if we square root a number that's raised to an exponent, that is the same thing as taking the exponent that's underneath the square root and dividing it by the index. So if we have the square root of x, x is raised to the first power. So that would go on top of my fraction. And then a regular square root has an index of 2. So the square root of x is the same as x to the 1/2 power. So the square root of 289 is the same thing as 289 raised to the 1/2 power. And this you can type in your calculator, and it will give you the exact same answer as if you square root 289. That's going to equal 17. Now, our index has changed here. Now they've actually written an index in of 3. So the cube root of 729 is the same thing as 729 raised to the 3rd power. And that's an exponent. Sorry, I wrote it a little big. And that gives me 9. And then 776. And now we have an index of 5. So that would be 776 to the 1/5 power. And again, if you type it in your calculator, that gives you 6. We're not going to worry about the more examples now. I think we're going to go over those. We'll look at those in class. That'll give us a little bit more time to look over this stuff. The last one I do want to cover, though, is this 0 exponent. Oh, nope, we've got a couple more after that. So anytime that you raise something to the 0 power, the whole thing's going to equal 1. So 8 to the 0 is just going to equal 1. Okay? So in an example like this, we would have 3. X to the 0 is just 1 times y to the 4th, and then times an x, which means 3 times 1, it's all just multiplied together. And that's all that's happening when we shove things together like that. It's just multiplication. So x has always come first. So we've got our coefficient. I'm going to write the x first, and then I'm going to write y to the 4th. Okay, so it's shoving pieces together, but when we write it, x has always come first in a compound expression like this. All right, last 2 rules real quick. Power of a product. So, power of a product. Sorry. Or did we already do? No, we didn't do those. Sorry, guys. I got to find my pieces here. Okay. X times y, and then raise it to the m. This is going backwards now. Is the same as x to the m power times y to the m power. So it's going backwards from what we did here. It's working backwards. Okay. Okay. So if your bases are different, but your exponents are the same, you can multiply the bases together and raise that whole expression to the same power. Okay? So in this example, negative 4 to the 5th times negative 12 to the 5th. The exponents are the same, so I can just multiply, let's see, 4 or negative 4 times negative 12, and I can raise all of that to the 5th power. Negative 4 times negative 12 is 48 to the 5th power. And then you can simplify it down further than that. Okay? So working backwards from that, x to the negative 8 times 5y to the negative 8. Exponents are the same, so I can take the bases, x times 5y, and raise them to the power of negative 8. So x times 5y is 5xy. Okay? Just you shove all the letters together to the negative 8. And we know if we have a negative exponent, we just put it under 1 and change the exponent to positive. All right, the power of a quotient. So if I'm dividing something. So if the exponent is the same in the two numbers that I'm dividing, okay, I can divide just the bases and raise them to the same power. Okay, so 2 over 3 to the second, I can break it down a little bit further and do 2 over 2 over 3 over 2. 2 squared is 4, 3 squared is 9. So I would have 4 over 9. Okay? In this example here, I've got negative x to the 5th over negative y to the 5th. So my exponents are the same, so I'm going to raise the whole thing to the 5th power. Negative x over negative y to the 5th power. But I can simplify it even further because a negative divided by a negative makes the whole thing positive. Okay? And that is it for these notes.